Hi guys, welcome back to my channel. Miss Clarke here. I am here to do another lesson with you. Today we'll actually be doing basic algebra, an introductory lesson. So I know that algebra is usually a really challenging topic for some people. So I said, let me start from scratch. Let's start from the beginning. All right, so let's begin. What is algebra? Like really, what is algebra? All right, so let me give you textbook definition. Algebra is that branch of mathematics that uses symbols, letters, numbers, etc. to carry out various arithmetic and other mathematical operations like addition, multiplication, division, finding the square roots, logs, all kind of things, all right? And algebra, the main premise of algebra is to solve problems, whether it's in our textbooks, whether it's what I give you, or whether it's being able to apply it in our real life to help solve problems. All right? So, in algebra, is always here. Why else I'll find about somebody else? Yes, so you want to find for unknown variables, which layman's do some unknown letters, unknown things, all right? So some key terms in algebra. Knowing these things are going to help you a whole lot. So you notice on top here, I have some stuff there, and that is going to help you. So a variable is an unknown number or quantity that can be represented by a letter in algebra. Usually you're accustomed to saying X or Y, but it can be any letter in the alphabet, A, B, C, D, E, F, straight down to Z. And then we can have variations to that, where you might see a little number to the top in terms of an index or power to make it a different variable as well. Our second key term here is an algebraic term. So an algebraic term, textbook definitions, yes, bear with me, having a proper knowledge and know-how of these things is going to help me when I start spitting a whole set of numbers and letters. Let's get the English part of the maths first, for cement things, and let me press now. So an algebraic term is a combination of letters and numbers, or more mathematically speaking, the letters are known as variables, as we just learned, and the coefficient is the number in front of the letter or variable. And if you go straight back to the top here, where we have 9y to the power 3 or 9y cubed, the 9 is known as the coefficient. The y is connected to a number 3 to make it y cubed, and the y cubed would be the variable, and the number 3 here is the index of power. All right, so going back to the second note, that an algebraic term would be the whole 9y cubed. So it's a combination of the letters and the numbers, or the variable and the coefficient. All right, and we have other examples such as 3x or 5y squared. Point 3. In algebraic terms, such as 3x, the x here, my apologies. So in algebraic terms, such as 3x, the x is the variable and the 3 is the coefficient of x. And what the coefficient does is tell you how many x's you have. So 3x would mean that you have 3 x's. So you have 3 sets of x's. X plus x plus x would give you 3x. In algebraic terms such as 5x squared or 5x to the power 2, the x squared would be the variable. So the coefficient of x squared would be 5, and the 2 on the top right hand of the x would be called the power index. And it's important for me to let you all know and let it stick with us that x squared and x are 2 different variables. Just like mangoes and bananas are fruits, but they are two completely different fruits. All right, so they are different, just like apples and bananas and grapes and all those are all fruits, they're all variables, but they are different. So x and x squared are different variables. All right, continuing, like terms are made up of exactly the same letters and powers. So example, 3x, 15x, 100x, they are all like terms because they have the same variable x. All right, they have different coefficients, but they have the same variable x, so they are like terms. Unlike terms, on the other hand, will not have the same variable, so it might be an x and a y, or it might be the same letter x, but they have different powers, where they have x squared, x cubed, and x, so those will be three separate variables. So the example that I wrote at the bottom is x squared and x. They will be unlike terms, two different terms. Or 3x and 3y, they are two different terms. In algebra, we use the term like terms and unlike terms. So let's get used to hearing and seeing those terms. All right? So let's do our first exercise. And it's to get us into grouping like terms. All right? So the instruction is sort out these terms into like terms and unlike terms. So what we want to do is to place all the like terms together. All right? So I'll give you all a minute to look it through. So you want to group things that have the same variables. You want to group all the x's together, all the y's together, all the whatever other letters together, and make sure that they have the same power as well. So I'll give you all a minute, and you watch my beautiful face. You know, you're going to be doing your work. How's it going? Hope y'all are getting through. Hope you have your pen and paper out and not having to now go scatter to get your pen and paper out. And I am ready to correct. If you're not ready, please pause the video so that you can give yourself more time. And when you finish, you can press play and I'll now continue, right? So these are the solutions. So we have the same numbers and I decided to highlight them in colors, corresponding colors. So all the x's, I highlighted it in green, such as the 3x, the 9x, the 7x. So the like terms in terms of x's would be 3x, 9x, 7x, as you can see with my cursor here on screen. Then I decided to group all the y's together. So I colored them in red, bright red. So we have negative 4y, then we have 6y, and then we have 4y. So that's the next set of like terms, and that's in red. You notice that in orange we have 4y squared. 4y squared is not the same as y. So y squared and y are different variables, so that's why I kept them separate. Okay. Similarly, x and x squared are different variables, so I also kept them separate. So for x squared, I highlighted it in blue, a very, very pretty blue. So we have 8x squared, then we have 12x squared, and we have negative 5x squared, and then negative x squared. All right, so that will be the next set of like terms that we group together there. Then we have 4p, which is in black. I didn't have any other 4p, so you just keep that by itself. And then you have 4y squared, no other y squared, so that's remain by itself. Okay, moving on. Some more key terms in algebra. So sometimes we would see some variables, such as the x and y in dark pink, combined with the coefficients, which is in blue, the 3 and the 5. And then in between the terms, we see a plus sign or minus sign. And we see some mathematical operations happening there. And when we see that, this is what is called an algebraic expression. An algebraic expression does not have an equal sign. When an equal sign comes into place, it becomes an algebraic equation. All right? So an expression would just have the mathematical operation of plus, minus, multiplication, division, in combination with letters and numbers. When there is a number like the 9 that's alone, not attached to a variable or letter, it is known as a constant. And the terms in this algebraic expression would be the 3x, the 5y, and the 9. And the mathematical operations, the main one would be the plus sign and the minus sign. So more definitions heading our way. So these are some key terms in algebra that would really help us in terms of having a good foundation moving forward. An algebraic expression, like I was sharing just now, is a set of algebraic terms linked together by signs such as a plus sign or a minus sign. And I have 3 examples there in red. First one is x plus 2, or the second one could be 10 take away 4x, or another algebraic expression would be 3x squared plus 5x take away 9. So you notice that there are no equal signs there, right? Just some algebraic terms with either a plus sign or minus sign combined together to form an algebraic expression. An algebraic expression consisting of 2 or more terms, like an x and a y or an x and an x squared, would be called a polynomial expression. And when it has exactly 2 terms, when an algebraic expression has exactly 2 terms, it is called a binomial expression. And poly meaning many, and bi meaning 2. So a binomial expression would be 2. If it's 3, what do you think it would be? If it's 4, what do you think it would be? All right, so those are some things that you can do research on if you so desire. You may not get this in a multiple choice test or asking on paper 2 question, but it's useful information to know. So there are some notations in algebra, and I'm going to go through them step by step. So the multiplication sign can be omitted when we write a product. Product means to multiply. So when we multiply, we can sometimes forget that multiplication sign when we write a product that contains a variable or more than one variable. So example, 8 multiplied by n. Instead of having to write it all the time, we could just write 8n. Similarly, y multiplied by z can be rewritten as yz. Then we have 3 multiplied by x, multiplied by y, multiplied by z. You'll see how long that is. We could condense it, make it much smaller, and simply write 3xyz. Algebra can be sweet, you know. All right. So note that we might be tempted to say 4 times 5 is 45. But we know that that isn't true. That 4 times 5 is 20. So that rule that I was just mentioning applies to when it's just numbers with letters and it's just one number and then letters, all right? If you have to combine numbers, you actually have to multiply it out. And it makes sense by my next point, where I have 5x, which could be written as 5 times x and I shorten it to be 5x. But what does 5x really mean? It means I have 5 x's, which is a x plus a x plus a x plus a x plus a next x, which gives us 5x. All right? As it relates to division, x divided by y can be written as x over y in the form of a fraction. All right? Or sometimes we would call it a quotient. All right? Similarly, 3/4 multiplied by x can be written as 3/4 x, or it could be written as 3x over 4. A coefficient of 1 is understood when a variable doesn't have a numerical coefficient. For example, a is the same as 1a, x is the same as 1x. And I'm going to break it down in layman's terms. I have an apple. Apple is the same as saying 1 apple. So a for apple is the same as saying 1 apple. Make sense? Think of it that way. And I want to stress that a is the same as saying 1a. X is the same as saying 1x. Often I would hear students saying x is 1, x is 1. X does not mean 1. X is the same as saying 1x. Remember, x is a variable that we're trying to determine the value of. Remember, algebra is about finding unknowns, solving problems. So if x is 1, then we don't really need to find something. So what we are simply saying, what I want to emphasize here, is that the coefficient, which is the number in front of the letter, the number in front of the variable, is understood to be 1 when there is no number in front of the letter or variable. So the coefficient of 1 is understood. So you don't have to write 1x, 1p, 1 apple. You could just say A for apple. You could just say apple 1. All right? I hope that is understood. All right? Moving on. X plus y means the sum of two numbers represented by the variables x and y. So these are two unknowns. We don't know what's the value of x, we don't know what's the value of y. So we call the unknown terms x and y. And if we add them or finding the sum, we put a plus sign between them. And knowing these things is important when CSEC would ask you to convert worded questions into figures and letters and algebraic expressions, right? Well, moving on. We have x minus y, which would mean the difference of two numbers represented by the variables x and y. Similarly, a multiplied by b, but we know that we could shorten it to ab, means the product of two numbers represented by the variables x and y. And we know that product is another way of saying multiply or multiplication. All right, current just went. I hope that this is still going on. And we have a divided by b means that the number represented by the variable a is divided by the number represented by the variable b. Moving on. Notations in algebra. Hi guys, and I'm back. currents went unexpectedly there. So I am just going to continue with where we left off. So we were talking about notations in algebra, and we were saying that x plus y would mean the sum of two numbers represented by the variables x and y, where x plus y would mean the sum of two numbers of variables that we don't know the value of. And x subtract y would mean the difference of two numbers represented by the variables x and y. Moving on to the third point, where we really stopped off there, is a multiplied by b, which we know that we could shorten to ab, would mean the product of two numbers represented by the variables a and b. And we know that product is the same thing as saying multiplication to multiply, right? Fourth point on the notations in algebra, we have a divided by b, which would mean the number represented by the variable a is divided by the number represented by the variable b. And we'd end up getting a fraction or something like that, right? Trying to move forward. And notation in algebra continue. We have a multiplied by a multiplied by a multiplied by a. So we have four a's that multiply by each other, and we're going to write that as a raised to the power 4. And I just want to highlight here that a to the power 4 is a multiplied by a multiplied by a multiplied by a, whereas 4a would be a plus a plus a plus a. So there's a difference. One is repeated addition, which would give us 4a, and we have repeated multiplication 4 times, which would give us a to the power 4. And then we have that little sign there. That sign means square roots. So the square root of a, that symbol there, means the square root of a. And then we see that same symbol with a 3 on the outside, which would now mean the cube root of b. Okay, so those are some notations that we need to know. So we're introducing it early. So when we're seeing it applied to algebraic expression, algebraic equations, we would know what they mean. So let's go through some examples of what CSEC may ask us. Write the following as algebraic expressions. So add 7 to the p. So that's English words. We now want to write it as an algebraic expression. So adding, so you know there's a plus sign you need to use, 7 to p. So it's going to be the same as saying 7 plus p. Question 2. The sum of m and n. Sum needs to add. So you're going to put m plus n. Subtract 13 from 25. Well, see, actually won't after that. But I wanted to say this for a reason. So if I'm subtracting 13 from 25, what would I write first? I'd write 25, take away 13. So order is important. What are you taking it from? So the bigger thing, and then you're taking from it the smaller thing. Or in this case, you're subtracting 13 from something. So you have 25 and you're taking away 13. So you need to put 25 first. Then you're going to put this minus sign 13. So just be careful. So now I'm going to do the next question with letters now. Subtract 4 from y. So in this case, what are you taking it from? You're taking it from y, so you're going to put that first, and then you're going to minus the 4. Last example before I give you all time to do on your own. So we have 7 times r. 7 times r. Times means to multiply. So you're going to have 7 multiplied by r. And we know that we can now shorten it to get 7r. So your final answer would be 7r. So you now have this exercise to do. 10 questions. I believe 10 minutes would be sufficient for you to do it. I'm not going to stare at you for 10 minutes. So you'll know what you'll need to do. Pause this video. And let's start back. This one, add 3 to A. So I'm going to go through it one by one. If you're adding 3 to A, what do you think that would be? Add, you need to put a plus sign, so you'd probably put 3 plus A, and you get A plus 3 or 3 plus A. Just discussing it with you before I actually share the answers on the next slide. Question 2, the sum of B and C. What does sum means? To add. So we should have a plus sign between B and C. Question 3, subtract 4 from 2C. So what are you subtracting things from? 2C. So you're going to put 2C, take away 4. Question 4, 5 times D. Times means to multiply. So you're going to have the numeral 5, multiplication sign D. You see me saying 5D. E multiplied by 6. Would you say I'm saying E multiplied by 6? Would you say I'm saying 6E? Number 6, the product of X and Y. And as we know, product means to multiply. So you're going to have X multiplied by Y, which can be shortened to XY. Number 7, divide 7 by R. What are you dividing? 7. So 7 will go on top, which will be in the numerator, and in your denominator, you're going to have R, what you're dividing by. Question 8, subtract 2 from the sum of A and B. So what you're subtracting from? The sum of A and B. So you have to find the sum of A and B. That would be A plus B, and you put that in brackets, and then you now take away 2. So you put minus 2. Add 3 to the product of P and Q. Product means to multiply. And question 10, twice of Y minus the square root of K. Twice is the same as saying 2 times. So we 2 multiplied by Y, which is 2Y. And then you're minusing the square root, so that's why you're using the sign. And you put K inside that sign. So let's look at the answers now after my oral discussions. So add 3 to A, as the same as saying 3 plus A, which is A plus 3. That's another way of writing it. Question 2, the sum of B and C is the same as saying B plus C. Question 3, subtract 4 from 2C. So we know we need to write it 2C first. So it'll be 2C minus 4 and not 4 and not 4 minus 2C. So be very careful there, guys. Question 4, 5 times D, which is same as 5D. E multiplied by 6, which is the same as saying 6E. Question 6, the product of X and Y, which is the same as saying XY. Divide 7 by R, which is the same as saying 7 divided by R, which is the same as saying 7 over R. Subtract 2 from the sum of A and B. So we find the sum of A and B, which is A plus B, which we put in brackets. And now we take away 2. Question 9, add 3 to the product of PQ. So we find the product of PQ, which is P multiplied by Q, and then we add 3. And then we know that P multiplied by Q is the same as saying PQ. And then we add a 3. So your final answer would be PQ plus 3. Final question and solution. Twice of Y minus the square root of K. So we know twice means 2 times. So you end up having 2Y minus the square root of K, where sometimes you put the 2 for the square root, or you mightn't put the 2. So you end up with 2Y minus the square root of K. So either or would be fine. All right, and that's it for class. Have a great, great day. And remember our watchwords. You are intelligent, you are beautiful, and you are going to achieve excellence. So continue to put in the work and you will reap the reward. So adios. See you next week for class and tune in tomorrow for Thoughtful Thursdays. All right, of this episode. So take care. Blessings. Bye.